Welcome to Precalculus Algebra, and here we're going to be working on evaluating functions. So for example, for the function f of x equals x plus 1 over x, let's find f of negative 1, f of 2, f of x plus 1, and f of 1 over x. So what these all have in common is you want to replace the x in the function with what's inside parentheses. So for example, if you have an x plus 1 in parentheses, you would want to put an x plus 1 there and an x plus 1 here. Okay, let's go ahead and go through these. So f of negative 1, that's going to be negative 1 here and a negative 1 there. So negative 1 plus 1 divided by negative 1 is negative 1 minus 1, which is negative 2. And likewise for 2. So f of 2 is going to be 2 plus 1 half. And then adding these two fractions together, we're going to get 5 halves. F at x plus 1. Right, so now what's in parentheses is x plus 1, so we're going to have an x plus 1 here and an x plus 1 there. So it's going to be x plus 1 plus 1 over x plus 1. And we don't have to combine these, we can just leave this as it is. Finally, f of 1 over x. We're going to put a 1 over x here and a 1 over x where x is down here. So it's going to be 1 over x plus 1 over, right? 1 over, and then replace the x with 1 over x. So this first 1 over x remains just 1 over x. And for the second one, so we have 1 divided by this fraction. And that's the same thing as taking 1 and multiplying it by the reciprocal of this fraction. So it's going to be 1 multiplied by the reciprocal, which is x over 1. And then this is going to be 1 over x plus x, and that's going to be our answer for the last one. Okay, let's try another one like that. So for the function g of x equals 2 minus x over 2 plus x, let's do the same thing. So first g of 2. So g of 2 is going to be 2 take away 2 divided by 2 plus 2. So it's going to be 0 divided by 4, which is 0. Moving on to negative 1, g of negative 1 is going to be 2 minus negative 1 divided by 2 plus negative 1. So it's going to be 3 divided by 1, or just 3. G of x plus h now. It's going to be 2 take away. Now, you replace x with x plus h, right? But you're subtracting off x, and because we're going to be subtracting off a sum when we replace this with x plus h, we need parentheses. So 2 take away the whole sum, x plus h, and then over 2 plus x plus h. And notice that we don't need parentheses for this last one in the denominator because it's addition. We're not subtracting off x plus h the way we were in the numerator. So in the numerator we get 2 minus x minus h over 2 plus x plus h. And that's as far as we can go. And then finally we have g of x squared plus 1. And that's going to be 2 take away the quantity x squared plus 1, which we need in parentheses, divided by 2 plus, don't need parentheses there, let's not even write them. So 2 plus x squared plus 1 in the denominator. So distributing the negative in the numerator, it's going to be 2 minus x squared minus 1, all divided by 2 plus x squared plus 1. And now combining like terms in the numerator, we get 1 minus x squared, because 2 minus 1 gave us the 1, and then divided by 3 plus x squared. And that's our answer. Okay, let's try one more. So here we have a function f of x that's written in pieces. So this is the first piece, this is the second piece, and this is the third piece. So this is called a piecewise defined function. Piecewise defined. It's defined in pieces. And what it's telling you is when x is less than or equal to negative 1, you want to use this rule. When x is between negative 1 and 1, including 1, you want to use this rule. And when x is greater than 1, you want to use that rule. Okay, so this is for when x is less than or equal to negative 1. This is, and including negative 1, right? Less than or equal to negative 1. Here x is between negative 1 and positive 1, including 1. And then this rule for when x is greater than 1. All right, so let's first start with negative 2. So when you plug in negative 2, which camp are we in? Well, it's going to be the first, right? Because negative 2 is less than or equal to negative 1. So we want to plug negative 2 into x here. So it's going to be negative 2 squared minus 1. And we get 4 minus 1, or 3. We use the top rule. Okay, then it's going to be f at negative 1. And then, so okay, negative 1, where does it fall? Which interval does it fall in? Well, still the first, right? Because negative 1 is less than or equal to negative 1. So we still want to apply that rule. So it's going to be negative 1 squared minus 1, which is 1 minus 1, which is 0. Then moving on to f of 0. Well, let's see. Now, of course, 0 is between negative 1 and positive 1. So we want to use this rule. And this says that the function in this interval is always equal to 2. F of x is 2 anytime x lies between negative 1 and 1, inclusive. So in other words, when x is 0, f of x is just equal to 2. There's nowhere to put x. The function is constant over that interval. Moving on to the next one, f of 1. Now notice that 1 still lies in that interval, right? Because 1 is less than or equal to 1. So that means f of 1 is also equal to 2. And then finally f of 2. Well, we've moved on to the third interval because 2 is larger than 1. So we want to plug 2 in here. And so the function is equal to 3 take away 2, which is equal to 1. Okay? So evaluating functions is going to be really important for what we do in calculus, so we want to make sure that we get extra practice on this topic now. Okay, until next time.